Hey everyone, let's take a look at problem 6 on the first midterm in spring 2020's offering of DSC 40A. So we're told to suppose we have a data set x1, y1, x2, y2, so on and so forth, and that we fit a regression line to that data set, and it has a mean squared error of m. Then we modify our data set by multiplying all of the x data points by c. So you can see here we have c, that should be an x1, I'm guessing, c x2, y2, c xn, yn, where c is some constant. And we're asked what the mean squared error of the new regression line is in terms of m. So what I'll do is I'll tell you the answer first, and then we'll walk through why that's the answer. And so the answer is that the mean squared error of the new regression line is still exactly equal to m. Let me show it to you. So let's suppose the old intercept and old slope are called W0 old and W1 old, respectively. Well, remember, the way we calculated these was by minimizing mean squared error and coming up with formulas, and we looked at those formulas in lecture. Now, for the slope, there were two forms of it. One involved the correlation coefficient r. The other was a more computational form, but they're both equivalent. I'll look at the more computational one right now. It looks something like this. And the intercept was the mean of the y's minus the slope times the mean of the x's. So what we'll do is first try and determine what the new regression line even is. So we'll try and determine what W1 new is and W0 new is. And then we'll plug those into the expression for mean squared error and see what we get. Okay, so what we're going to do is find W1 new and W0 new. And we'll start with W1 new. And before we do that, I need to show you a fact. So fact. The mean of c times x1, c times x2, so on and so forth, c times xn is equal to c times the mean of x1 all the way through xn. Okay, so what this means is that the mean of our new data set's x value, so cx1, cx2, so on and so forth, cxn, is just whatever the old x mean was, x bar, multiplied by c. So I can write this as, cx bar is equal to c times x bar. Okay, and we're going to need that when calculating our new slope. So let me scroll up a little. You can see the formula for the old slope. So the new slope is going to look similar. It's just wherever I have an xi, I'm going to replace that with a c times xi. And wherever I have an x bar, I'm going to replace that with a cx bar on top of all that. Okay. So I'm still going to have a sum over n data points. I'll have cxi minus cx bar multiplied by yi minus y bar. And on my denominator, I'll have cxi minus cx bar all squared. Okay, let's start simplifying. Well, it seems like in this term, there's a common factor of c. So I can pull that out of the expression. So I have c xi minus x bar times yi minus y bar. And on the denominator, it seems like within here, there's also a constant factor of c that I could pull out. But since this term is being squared, when I pull out that constant from the term, I'm going to have to write c squared, not just c. So when I pull out the constant here, I have c squared times xi minus x bar squared. Now this looks pretty familiar. It almost looks exactly like the old slope, which you can see if I scroll up here. It looks very similar to this thing. It's just that there's a c and a c squared on the denominator. Or a c on the numerator, c squared on the denominator. So you'll notice the numerator's c will cancel with one of the c's on the denominator, and then since it's a constant, I can pull it out of the sum and write it over here. And so my new slope I can write as 1 over c times something that looks like the old slope. In fact, this is exactly the old slope. So I can see the new slope, W1 new, is 1 over c times the old slope, W1 old. Okay, great. So that's one of the facts we're going to need. The other thing we're going to have to do is try and determine what the new y-intercept is. Well, that's going to be the mean of the y's minus the new slope times the mean of whatever I'm using as my x variable. Well, in that case, or in this case, that's the mean of cx. Okay. Well, we didn't change the y's at all, so the mean of the y's is also not going to change. I just calculated what my new slope is. It's 1 over c times my old slope. And we just looked at the fact that the mean of c times x is just c times the mean of x. And you'll notice the 1 over c and c cancel. So I'm left with y bar minus the old slope times x bar. And that's exactly the formula for the old intercept. Right? There's no c involved here at all. So it turns out that the new y-intercept is equal to the old y-intercept, w naught old. Awesome. So where does this take us? Okay. Well, so to summarize, the new slope is 1 over c times the old slope. And the new intercept is the same as the old intercept. Well, who cares? Well, we need to evaluate all of this in terms of the mean squared error of our regression lines. So we're told that m is equal to the mean squared error of the original regression line. So that'll be 1 over n times the sum of I going from 1 to n of yi minus the old slope minus, the old intercept minus the old slope times the x's. That is the value of m. Okay, it's the mean squared error when I plug in my regression, or like my optimal parameters into the expression for mean squared error. The new mean squared error is what I get when I plug in my new optimal parameters. So W naught new and W1 new. So let's do that. I'm looking for the value of this. But I've already written these two things, the new intercept and the new slope, in terms of the old intercept and the old slope. So let me use those facts to see where we can get. Also, there was a mistake here because this should have been a c times xi. That was the whole point. We multiplied all of our x's by c before fitting this new regression line. Okay. So I have 1 over n times the sum of yi's. First, let's evaluate the new y-intercept. We just showed that it's the same as the old y-intercept. So I can write this as w naught old. What about the new slope? Well, I found that the new slope is just 1 over c times the old slope. So I can write this as 1 over c times w1 old multiplied by cxi. All of this is squared. And what do you notice? Once again, the 1 over c cancels with the c. And so we're left with this. W naught old minus w1 old times xi. And this looks shockingly similar to the mean squared error of the old regression line before we multiplied everything by c. And in fact, it is the same. It's exactly the same. Right? This right here is no different than this right here. So the answer is the new line's MSE is also M. And we just proved it. The way we did it was by finding the new slope a new intercept of the line and plugging those in to the formula for mean squared error after we found a relationship between the new slope and new intercept with the old slope and old intercept. So that's it. Mean squared error of the new regression line, it's just m.